Okay. So I guess kind of the first thing I wanted to talk about, Mike, was with MDA. I found it really interesting that, we think of anything to do with space as, being a huge company, but it started in a basement, which I thought was very interesting.
Yeah, for sure. Yeah, and McDonald Detweiler and Associates is where it all began. Two gentlemen, John McDonald and Vern Detweiler, started McDonald Detweiler and Associates back in the day. At the time, John McDonald, grown up in British Columbia, and then had gone off to do advanced degrees with in MIT, and ended up, working in labs and actually doing some professor work down there once he got his advanced degrees. Um, but was noticing and was affected by the fact that, like himself, a lot of strong technical talent was leaving British Columbia at the time and or leaving Canada.
Mhm.
And yeah, I wanted to go back and create a company that would engage engineering talent for the future. So that was always on his mind. He ended up getting a job at UBC, so he went back to UBC and was able to work at the university there. And then while he was working there, that he kept thinking about this. And then over time left UBC to be able to create McDonald Detweiler and Associates. And so yeah, I just started out as a few people trying to take on hard engineering challenges, and around the same time, Canada was getting into space, so that was a good hard engineering challenge to engage people in.
Yeah, I love that story. You guys are working on like the Lunar Gateway now, but you all started in a basement. It's such a cool
Absolutely,
story.
yeah.
Yeah. So tell me a bit about what MDA does now.
Sure. So these days, MDA is focused on being a pure play space company, a global leader in the space sector, headquartered in Canada, traded on the Toronto Stock Exchange. We organize our business into three business areas. One of those is geointelligence, which is all about observing the Earth and humanity's activities on the Earth. Our sort of principal asset in that regard is a satellite called RadarSat-2, which we own and operate. And that provides images of the Earth every day as it flies around the Earth in its orbit. And then we deliver that data or analysis that we've extracted from that data to customers around the world. So that's like one area that we work on, is observing the Earth from satellites and seeing what's changed and what's going on. A second area would be in the communication satellite business. We build satellites and deliver those to customers that operate satellites. We've done that for 50, 60 years, ever since Canada started having satellites in the communications sector. And have delivered over 300 different satellite missions over time from our satellite business. And so we're currently delivering satellites to communication projects. We contribute satellite subsystems to those that are making geosynchronous orbit satellites, which are very large satellites that are in positions up in geosynchronous orbit. And then we create technologies for low Earth orbit, or LEO satellites, that are much, much closer to Earth. And we've scaled up a bit in that business. We not only provide subsystems to others that are building satellites, but now we are also taking the role of satellite prime. So we're building the full satellite ourselves. The third and final business area is robotics and space operations. Robotics and space operations is where we built the Canadarm, the space robotics that Canada is quite famous for. So we built the Canadarm for the space shuttle years ago, and it flew on over 90 different missions with the space shuttle, which then led to Canadarm 2, which was the robotics for the International Space Station, which has now operated for over 20 years in orbit. And as you mentioned, now we're working on Canadarm 3, the new artificial intelligence-based robotics for Lunar Gateway, a new space station that's going to orbit the moon. Those teams also work on rovers. We've had rover technology on Mars for over 15 years, and starting to turn our eye towards rover technology for the moon as humanity returns to the moon over the next couple of years. So that's kind of what we're up to across the country.
In regards to, like, if you mention Canada and space, probably the first thing people either mention Chris Hadfield or they'll mention the Canadarm. So is it a big source of pride for MDA to be involved with creating the Canadarm and something that has kind of become such an iconic part of Canadian culture and history.
Absolutely. Like there's like no end to that pride. I agree with you that Canadians very much relate to it as well. We were involved in some polling and focus group interviews across the country a few years ago in 2018. And yeah, it's not just that it's Canada's most sort of iconic space innovation, it's Canada's most iconic innovation. So when you ask Canadians, what are big inventions or big innovations that have occurred in technology in Canada, they'll say Canadarm. It'll come out first. It's interesting, like people have invented medicine and cured big diseases and like all kinds of crazy things. It's just people don't know about it. So it's awesome that it's a simple enough concept to have space-based robotics with that Canadian emblem on it, up there at the International Space Station. And the fact that it's on our currency on the back of our $5 bill, that's a source of pride. And by the way, a source of jealousy in other countries. When I'm down at like senior leaders in NASA will have a Canadian $5 bill on their desk. Sometimes I've had people like that, very senior positions in the U.S. government, with Canadian $5 bills on their desk, and they use it to be able to say, like, look, like other countries, it's so important, it's on their currency. This space stuff. So yes, people are envious of the recognition that we get for our space technologies here in Canada. But it is a tremendous source of pride, both for Canadians and certainly for our company.
When we think of space, obviously the United States, Soviet Union / Russia tend to get a lot of the attention. Do you feel like Canada's role in space, whether it be space exploration or even just, helping to build the International Space Station, tends to get kind of swept aside amid the larger countries who have been involved in, like the moon landing and such, even though Canada had a very large role in that as well?
Yeah, I think that within the space sector itself, we are certainly recognized. So within the space sector itself, people know what Canada has accomplished, is able to accomplish, and there's a good level of recognition and respect. Our technologies are part of that, and our professionals are part of that. The astronaut corps in Canada has a tremendous level of respect in the International Astronaut Corps. And then our technologies are well recognized in terms of what we can deliver. So that's there. Potentially from a general public perspective, they'll see lunar landings and United States flags planted on the moon or what have you. So that probably gets more public recognition. I don't think probably the general public wouldn't, be aware of all the things that Canada contributes to space. But within the space community, we're certainly, recognized for punching above our weight.
And tell me a bit about your involvement, obviously with the Canadarm3, but the Lunar Gateway.
Yeah, so Lunar Gateway will be the new space station that will orbit the moon. It'll have a lunar orbit. And so just for perspective for folks, the current space station that we have today that orbits the Earth, that all of our astronauts go to, it orbits the Earth at about 400 kilometers up. And the new space station, Lunar Gateway, which will orbit the moon, it'll be 400,000 kilometers away. So much longer distances, of course, to get out there by the moon. The Lunar Gateway is an important outpost. It won't necessarily have people at it all the time. And so it has to be able to take care of itself autonomously, and then, or remotely with support from humans on the ground here on Earth. And then vehicles and astronauts will visit it. And the idea is it's part of what's called the architecture for the lunar program. So people could take off on a rocket, fly to Lunar Gateway, dock, maybe spend a day or two there doing some things, and then transition to a lunar lander, and then go from the gateway down to the lunar surface, spend a period of time living and working on the moon, and then return on their lunar landing vehicle back to Gateway, get on their other rocket and come back to Earth. So that's all just part of that architecture overall. And then of course you can have personnel aboard, Lunar Gateway supporting operations on the moon. All of this is to ensure the effective support for the activities on the moon, but also to learn to operate in a manner that supports further human exploration in deeper space, so that Gateway can be an outpost that's part of trips to Mars and back, for example. So that's all part of that picture. Our role in this is to deliver Canadarm 3, which is the next generation artificial intelligence based robotics. As I mentioned, the station won't be staffed all the time, won't be crewed all the time, and it's a long way away. As a result of those two things, we'll operate robotics from Earth, but it needs to be able to run autonomously. So we can give it a series of instructions, and then it can operate robotics and complete its tasks autonomously for a period of time, many days. And then we would talk to it again and see how things are going, and give it some new instructions. And so the robotics would be used to finish assembling Gateway, to be able to maintain Gateway, to be able to assist with docking and berthing, to be able to manage payloads, scientific payloads that might be put on the outside of Gateway. So there's a range of tasks that it would be involved in to make the space station function well in orbit around the moon. In addition to delivering the robotic system to Lunar Gateway, we'll also be operating it. So right now, the current Canadarm2 robotics is operated by robotic operators that work for NASA from Houston. For Lunar Gateway, Canadarm3 will be operated by robotic operators that work for MDA in Toronto. And so we're building a new facility there, a new global headquarters and robotics center of excellence, which will include multiple operation centers for on-orbit robotic operations for the future.
Is it exciting to deal with those challenges with the Canadarm of, like you said, operating it from 400,000 kilometers away, but also now being able to operate it in Canada rather than having it operated either on the space station, space shuttle, or in Houston?
Oh, it's tremendously exciting. It's hugely engaging. It should be for our workforce for sure. Whole new levels of responsibility, whole new levels of technology. We engage. We've hired a lot of new people to be involved in this. We're engaging, different companies across Canada to help us with this. So it engages a lot of Canadians within it. And then certainly, I expect it to be a source of pride in the future as people probably listen to space-based comms someday, and people are talking about operations, and they're talking about MDA Toronto, on the radio network, doing this thing with robotics. That can only be a future source of pride.
Why do you feel people have latched on to something like the Canadarm so strongly? Like you said, we've had many other, insulin, for example, all these other advances that we've had, but people really do latch on to the Canadarm to the point where it's on our money. Why do you feel that we have so strongly?
I think it's a big feat. I think it's a big feat. Not that any of those other challenges that we've conquered in Canada aren't big feats, but I think it's also very visual, and it's also very accessible. So you can say that, we invented insulin, and unless you understand, what insulin can do and how it can really change people's lives, and that, people with diabetes now have a totally different life profile than they would otherwise. That's a phenomenal achievement. But unless you're involved in that, you don't get it. It's not as accessible to you. I think that, innovation around key technologies that are visible and accessible are therefore engaged by the full range of the population. You have 100% potential engagement in that achievement. I think it's just it's a bit science fiction, right? You're building robotics and you're putting it into space, and then there's astronauts with Canadian flags on their shoulders, like Chris Hadfield, that are operating that robotic system and using it. And again, it's all the inspiration that comes from exterior vehicle activity, EVAs, in space, as astronauts go out and do spacewalks and build things and fix things and stuff. Astronauts engaging with Canadarm in orbit outside of space station. That's just only exciting and inspirational for people. So it's visual, it's accessible, and it's inspirational.
What's the process like? Because when we think of the general public, they kind of only really notice when a satellite's in orbit, but there's a whole thing that goes on beforehand. I guess from the point where you guys are getting the project to its finished, how long is that time take to build a satellite or build a Canadarm or do all the testing and all of those things?
Yeah, it's quite a journey for sure. One of MDA's biggest strengths is at the start of that journey. So our customers will often say that they really just enjoy working with MDA, that our technical innovation to be able to develop the solution for a space mission is very, very excellent and very collaborative and very engaging. And people, our customers really appreciate that, whether they're government agencies or commercial customers that are buying from us. And so, these things always start with a high level mission requirement. What do we want to accomplish? And then what we want to accomplish then turns into a series of requirements. And okay, well, if we want to be able to do this or do that, then these are the 6 or 10 big requirements that we have for this system. And then it's a journey to decompose those into lower levels of detail to turn our requirements then into a design. All agree on that design, and then go and build that system. A lot of testing, to your point, happens along the way, with improvements in modeling and simulation. You get the opportunity to test your thinking as you go, so you can have a high level concept right at that initial what do we want to accomplish level, and what would it look like, and test those ideas. And then as you get down into the details of a design, you can have more detailed engineering models or simulations to model and test your thinking. If you're building a communication satellite, you can model and test the communication signals and how they're going to like propagate and work in orbit. And so it's a great time for doing these types of things with the technologies available to the design and testing process. Then we assemble these things, we build them, go out and source all of the elements from different companies all over Canada and around the world. We'll bring them into our labs and manufacturing facilities and assemble the solution that we've all designed together. We'll have very different levels of what's called clean rooms, which are like highly controlled environments you'll see on TV and stuff, with people wearing like white coats and hair nets and all the rest, to be able to make sure that they're not bringing any dirt into that environment. So very, very clean manufacturing and assembly environments. And then have a range of testing that occurs. And so our facilities will include a range of different test chambers where we test the subcomponents and the final completed systems to make sure that they can function properly and work well in orbit. And a lot of testing goes into this. When you launch something into space, it needs to work well the first time, and then every time thereafter. So a lot of testing goes into space systems. From a satellite perspective, satellites these days, 2 to 3 years is a time, often around 3 years, to be able to go through that whole process to build a new satellite from when you first start talking to somebody about it. Some of that's decreasing, some of that's getting faster, so that as you get into more productized designs and you are reusing a previous design, then you can accelerate that tremendously. In addition, the production rates are going up. On one of the projects that we talked to, where we might be the manufacturing partner to do the final manufacturing, assembly, and test, we'd be building a couple hundred satellites for that customer at production rates of up to 1 satellite per day would be coming out. So, it might take 2 or 3 years to get to those first few production ones, but then after that, you're pumping them out, at a pace of 1 a day, once you've got everything all lined up. So that's a changing aspect of the space industry, whereby with low Earth orbit or LEO constellations, where you're building hundreds of satellites, you get into we're going through a transition to get into a higher production rate environment now for space activity.
Everything we've talked about, especially a space station orbiting the moon, would have been science fiction just 70 years ago, which is not a huge amount of time ago.
Wow.
So do you ever have to pinch yourself and be like, I'm involved in something where it's making history, and it's something that'll be talked about for centuries to come? So is it ever a case of like like you said, you have to pinch yourself and go like, this is a really cool job that I have?
There's no doubt about it. And I do that 70-year thing that you're talking about, like, all the time. Like, when you think about, from an aircraft perspective, from sort of first flight to then, really have an aircraft, that was like a 50 or whatever year thing. And then like this 70-year thing that you're talking about on the space side. And then what's been accomplished is just wild. And so to be thinking about that, and that the technologies you're contributing and the problems that you're trying to solve is like starting the next 70 years. And like, holy crap, like what's that going to do
Mhm.
in terms of like what we're able to accomplish? And so, some topic areas, it seems sort of like incremental, and then some of it is just not incremental. It's like big steps. So, when you start to get involved in studying things like, nuclear power or nuclear propulsion, which will dramatically change, the speed and the timings to get to the moon or to Mars. That'll be very interesting. Or the ability to have power sources on another planet that can, power habitat, and, working on the next generation of habitats and, robotic systems on vehicles and mobility systems for other planetary systems, so people can live and work and grow food and move around, and setting up the communication systems which we're involved in to make all that work and be able to talk to people back on Earth. Like, and even all that, when you just say those things, that's still just like the next 10 years, like 5 to 10 years. That's not the next 70. So like just the potential of what we're about to embark on, and what we can start to do in space now over the next few decades in terms of, being able to have on orbit, capability and on orbit manufacturing. There's a whole group of people that look at what can we assemble and build, and what kinds of materials can we create in zero gravity environments. In addition to human health, people are studying like how can you create like human retinas or alternative organs and stuff like in zero gravity environments, and come back down and like have different applications for medicine. Like there's all kinds of very interesting problems that people are trying to solve, not trying to solve, are realizing that they can solve
Mhm.
with the increased accessibility to space. And so that's it's tremendous to be a part of and tremendous to imagine, which some days is difficult to imagine. Like we can't see past, there's so much happening in the next 10 years, it's hard to see past to the next 50.
Kind of leading into the next question with some of the things you said, and I mean, just even the fact that we're talking, face to face, able to see each other. Why is space travel or space exploration, or even just getting into space a little bit, why is that so important for us here on Earth? For either the technologies we develop or the perspectives that we get. Why is it so important for us to kind of reach out there?
There's a number of different levels to that. I find that, at sort of like the base human level, space exploration, having space stations, going to the moon, having astronauts, men and women that are engaged in that from around the world. um, there's a big inspirational element to that, in terms of just the whole notion of going after your dreams, and trying, that humans can solve impossible things. And so I think that like that's one of the biggest, sort of softer spin-off implications of international space programs, is that engagement back with the just the general population to study science, technology, and engineering and math, which is like the STEM subjects, get involved in that. And then just the inspirational aspect, which is like have a dream, go for it, accomplish it. Like humans can do all kinds of things. So I think that spins off into all aspects of society. And I bump into that all the time. I'll bump into people in all kinds of different industries that'll say, oh, when I was a kid, I dreamed of space and I saw an astronaut, or I met an astronaut, or I talked to somebody or whatever. And it just totally inspired me. And I never made it to space, but now I'm the president of a bank or something. But like it causes that, I
Mhm.
can accomplish anything feeling. So I think that's really cool. From a technology perspective, though, sorry, a second level would be that from space, we can appreciate Earth, in a different fashion. And so the ability, for example, to monitor climate change. There's about 52 variables that people monitor around the world for climate change, and 26 of them can only be measured from space.
Mhm.
So just the ability to monitor, measure, and manage our own planet, our activities in space have a tremendous impact, from that. And then there's an enabling aspect from space in things like communication. Back in 2016, the United Nations declared that access to the internet was a basic human right. Well, there's lots of humans that like don't have access to a fiber optic cable so that they can access the internet. These space-based networks that we're building now will ensure like that everybody, doesn't matter where you live, is going to be able to access high-speed communications in time. And so the fact that everybody can access education, and everybody could start a business and engage in commerce globally, no matter where you live, is a tremendous impact in terms of just the future of Earth. So I think that's pretty interesting. For the stuff that we do in space, though, and the technology we've developed to be up there, it pushes boundaries. So space is a challenging environment, distance, environmental, climate, temperature, like all kinds of stuff here. And so it causes you to solve challenges that you wouldn't otherwise solve. Like people will talk about, I don't know, Velcro or something came from the original astronaut program or something. So you had to have a in a zero gravity environment where you couldn't push a dome and have something resist it. Like something had to just close and grasp. And therefore Velcro was invented. Like that's kind of cool. So like all these things get invented by this very challenging environment with different characteristics to it that we can then bring back to Earth. So I think that's a tremendous benefit to Earth for us. Just in our robotics, for example, we've had to, over the last 40 years of being involved in robotics, develop control systems that we could operate remotely that had to work safely with humans in close proximity to very high levels of dexterity or grasp or touch, like a human hand. And so that's a very, very hard problem that we had to solve. And so, but then we've been able to take those control systems, for example, and it's transitioned on Earth into robotic systems with other companies for brain surgery, so that they could have a robot that works in close proximity to a brain surgeon in a critical environment, to very fine levels of dexterity. And so you get technologies that each of us develops in our corner of the space industry that we can bring back to Earth, which contributes, to society, the advancement of society. We're now building adapting those same control systems to robotic systems that can be used for breast cancer diagnosis and treatment in the future. So all kinds of different problems you can now start to solve by adapting the technologies that space pushed us to create in the first place.
And why is it so important that Canada be heavily involved in this, whether it's the Canadarm or developing satellites or even just our astronauts being a part of the space program? Why is it so important that Canada is part of all of this?
I think that, it is a fact that Canada is involved in all this, and it is a fact that we are leaders in all this. We were the third country in the world after the United States and the USSR to have a satellite. So the third country into space with a satellite. And we've been there from the beginning in terms of doing that. As a nation, space-based technology is important for us due to the size of our country. I wasn't there, but I'm sure that was part of the original conversation, which is that we're going to need communications across this vast country, and space-based communications is going to help. We need to monitor, 3 large coasts around it, one of them covered in ice. So the whole reason we were in radar-based satellites in Canada is from that task. So we need to get up into space and we need to monitor all of these things. So there's things about us as Canadians that are definitely served from our benefit in space. Just like any other country, though, space is a huge economic driver. Space generates what a government worker would probably call a HQP, or a high quality position. So these are high quality jobs that have above average pay. And those types of people tend to spread that around the economy in a good way. So the economic multipliers for space are such that studies in Canada have shown that a dollar that goes into space is about $2.50 into the economy in terms of the economic multipliers that come directly from that work. A lot of countries have that aspect in their actual space strategy. So like the United Kingdom, for example, would say that they have a space program now. They're trying to catch up after many years of not having one, specifically for economic stimulation and advancement. So when we put money into space, it drives a good economic effect. And then I think that thing we talked about before, you're talking about the astronaut corps and the inspirational aspect. So in addition to space itself driving a strong economic impact, us having Canadian astronauts in orbit, motivating and inspiring people to go and accomplish their dreams, all of that causes a population to have pride and confidence to be able to take on whatever challenges in whatever domain, whether it's the sciences or the arts, to go and take it on. Like, look what we can do.
Mhm.
Uh, and I think that's great for any country.
Now, for my last question, MDA starts in a basement, and you guys are now helping to build a space station that orbits the moon. What's ahead for the company?
Yeah, tremendous opportunity, really. I think that if you look at the different areas, if you look at geointelligence, we're currently investing in our next generation of Earth observation satellites. We're creating a radar-based satellite constellation called Chorus. That'll be developed and launched over the next few years. So we're accelerating all of our access to space-based Earth observation. We'll spend some work looking at creating, how do we make that information available from space more and more accessible to people? On the communication side, we continue to work on the next generation of digital satellites, software reconfigurable satellites for orbit that will allow much more performance to come out of space-based communications. We're very proud that our technologies are being now used increasingly by governments for sure, but mainly corporations all around the world for space-based communications. Our recent contract award to Globalstar, which causes us to provide them with 17 new communication satellites and an option for 9 more. Globalstar has recently announced that network, they're going to provide 85% of that capacity to Apple for the connectivity of iPhones to satellites. So we're very proud to be part of that whole conversation and delivering that capability to Globalstar to support their customer. So it brings increasingly space-based technology into everyday life. It's a big part of our life today, but increasingly part of everyday life. In space exploration, lots of commercial opportunities for robotics. There's new commercial space stations that are now being developed and designed. So no longer government-based space stations, but companies created to build and run space stations. We have opportunities to be part of all that with sensors and robotics. New types of spacecraft that can go out and inspect and repair and change the orbit of different satellites and service them. There's a whole new market emerging to service the high numbers of satellites that are in orbit. And those same technologies will be used to build industrial parks in space, where we'll have space-based manufacturing and the like. And will be a very big part of the return to the moon or other planets with our robotics capability and our rover capabilities to provide transportation systems to the moon. We've signed an agreement with Lockheed Martin and General Motors to be able to develop a next generation of rovers for the moon that we look forward to participating in. It'd be very cool to have a rover booting around the moon with an MDA logo on it. That would be kind of cool. So that's all coming in the future as we then talk to others about what kind of robotic solutions are needed for further planetary exploration as we go beyond that further into the future. So lots of opportunity for us to continue to be part of a growing space market in those different ways of advancement that we see coming over the next decades.